Welcome everybody. This is ClojureScript in ClojureScript. So if you were thinking you're about to hear something else, then you're probably in the wrong place. All right, let's get started. All right, so my name is Joel Martin. I am a principal software engineer at LanoCloud, where we're doing some really cool stuff with Clojure and cloud. And I'm probably actually best known in the open source community for having created NoVNC and WebSockify. NoVNC is an HTML5 VNC client. WebSockify is a WebSockets to TCP socket bridge. I created it so that NoVNC could connect to normal VNC servers. NoVNC and WebSockify are used in, included in OpenStack and OpenNebula, Gannett Web Manager, and a few other things. Some contact information. All right, so we're here to talk about ClojureScript and ClojureScript. ClojureScript and ClojureScript is a fork of ClojureScript that lives here. It is a port of ClojureScript to ClojureScript. More specifically, it's a port of the Clojure parts and the Java parts of the ClojureScript compiler to ClojureScript. So the question is why? Why would you want to do that? And I think the best reason I can give is to show some examples of what's possible. So, ClojureScript.net, I have a local copy, but that is the real web address of the online web REPL. Just to lead into this, there's no JVM. I don't think I invoked the JVM at any time during my presentation. So, let's see here. Let's start with some trivial things. Let's make it a bit more interesting. Maybe? Yep. Okay. All right, so there's a bunch of stuff that just happened there. There's macros, metadata, just a bunch of things that are coming together to make that possible. But that's still, it's still pretty tame. I mean, I could be faking it, so let's step it up a little more. Okay, anybody know what that's going to do yet? All right, now the nil at the end there is just I didn't want the result, the value to be printed and evaluated ahead of time. But let's, okay. That is expected, as is that. And lazy evaluation with a side effect. And if we do that again, no side effect, because it's already been realized. Okay, so Mike Anderson, I have to give him credit for that example, but I thought it was a pretty cool example just to show that we really have a full REPL here that has a lot of the normal things you would expect to have in a ClojureScript compiler. All right, so again, no JVM here. This is all happening in JavaScript in the browser. All right, so a web REPL that's already been done, backed by Clojure running on the JVM, or ClojureScript running on the JVM. But there's some other interesting things you can do, and a lot of these examples you can do using a server on the back end. But I think there's a lot of applications that new applications that can be enabled by this. And you don't always want to be having a server running just for some of these things. So, all right. So here's a little fairly trivial game of life. This is a ClojureScript application, and one of the things I've done is I've added a debug REPL to this application. All right. So this is somebody else. I wouldn't have named it quite like this if it had been my choice. All right. So what I just did is I looked at the the game state atom, and it happens to be uh, 1200 either nil or alive values in a vector. So now let's do something with that. One more. There we go. So what I just did is I used rand nth to do about 2/3 nil and 1/3 alive, and just reset the game state to that. So one of the powerful things here is a pretty trivial example, but this does allow you to, using ClojureScript, not JavaScript in your JavaScript console, allows you to actually use ClojureScript to introspect on your ClojureScript application while it's running, change things while it's running, and generally do some debug and other REPL-style development, which I think is pretty powerful. All right, so one of the other things that this enables, so here I have an HTML file that I've created. There's another project that I'm working on I haven't quite released yet, but we'll be releasing it in the next week or two. I'm calling ScriptAnnie. It's actually pretty small, but essentially what it does is it allows you to register script tag types with a handler for those script tag types. And so I'm using it. I'm pulling in a debug version of the ClojureScript and ClojureScript REPL that I've compiled because it's debug. I do the require here. And then this is JavaScript, but in JavaScript I'm initializing the REPL, and what this is doing is really just setting up some of the output streams. And then I call ScriptAnnie to register with this MIME type a function, callback function, that will call the REPL's read-eval print on the text that's passed to this function and print the return value. And now I can do something like this. And we'll need to do something to let you know that it actually worked. All right, now I will reload the page. Voila. All right, now one of the things you might want to do though is from normal JavaScript you might want to then call that. In Firefox, there's a little bit more of the W3 standard for script invocation implemented, so you don't need this, but for now in WebKit you do need this in any JavaScript script tags that are going to refer to ClojureScript or whatever ScriptAnnie scripts you registered that happen prior to when you want to use them. You have to use this barrier. Again, not in Firefox though, it handles this for you. So let's actually remove this. And there you go. All right, now it also, another option for something you can do is instead of putting this right in line, you can also pull it in from a file, and that file, I'll show you here, is just defining a new function and printing out what you see here, the print from bar. And of course now I can, from the JavaScript console, call something like that. Okay, so that's some web examples of why you'd want ClojureScript and ClojureScript. There's also another thing that this enables is a node REPL, node.js. For those that aren't familiar with Node.js, I think everybody probably is, but Node.js is basically Google's V8 JavaScript compiler. integrated with an evented loop system and a bunch of libraries that make it useful. All right, so this is the ClojureScript REPL plus analyzer compiler, but running via Node.js. And so we can do all the same things that we did before. This is basically equivalent to the ClojureScript.net that I showed you earlier, and I could go through that, but okay. One interesting thing you can do here is so I have a node.cljs.js. Well, actually, it came from .cljs. And that is basically a single file compiler, a wrapper. And the run.js there is just a wrapper that sets up like the print, the print streams, and then loads and invokes using the Google Clojure library require statement. Anyway, so here you have basically like Unix-style shebang script, but using ClojureScript. So that's pretty cool. I mean, you can do that with Clojure too, and I have an example of that. Now, here's one thing though. So the ClojureScript version for startup speed is about twice as fast on this system. It can be, depending on your system, it may not be, the difference may not be quite as big, but in general, the startup time is faster for this. And this is ClojureScript and ClojureScript unoptimized. So now, of course, any long-running program is going to perform quite a bit better using the Clojure version. But this is just an example. Often when you're building small scripts like this, you're more concerned about the startup time than the long-run time. And we also have I'm sorry? Yeah. Same thing, I mean. So it's really just the shebang line that's different. All right, so we can also do like the full compile using ClojureScript and ClojureScript compiler. Now, one thing to note here is we're not fully self-hosting yet, so I do have to do a little hack, and I apologize for that here. So I'm creating the output directory ahead of time so that I can do the hack. Goog.js is a little wrapper that I created that allows the Google Clojure library to do file I/O when it's running in Node, which surprisingly it doesn't have built in. But the hack I have to do is this. So the core it's not the part that's not self-hosting yet is core.clj and core.cljs. The full thing can't quite compile yet, so that's still an outstanding task. But I have the compiler here. Sorry, I have to refer to this. All right, I have a simple hello program, and I'm going to compile it. And I have a different wrapper because it's in a different subdirectory. It uses out2 instead, but all right, so that was, when I did that compilation, it generated this whole data structure, pulled in all the dependencies, did it use Node to do all the file I/O, and compiled the hello.cljs file right there. Okay, so that's the why. And I think the examples give a better explanation of why you might be interested in this than anything else. Now I'm going to talk a little bit about well, let's see, what is next? There was a dream that was Clojure and Clojure, and it's still, I think, we'd have to ask Rich if that's still in the plan or if he still thinks that could happen someday. But basically the dream is that Clojure is implemented entirely in Clojure itself, except for maybe a very small platform-specific core. And in fact, Clojure does kind of achieve that more than a lot of languages that I've had experience with. The core that is in Java is pretty small, but it could be better, and it would allow Clojure to be more easily ported to other platforms and more quickly, among other advantages. And ClojureScript itself is kind of a step towards that goal. A lot more of the compiler is actually implemented in Clojure, or ClojureScript. And I kind of see ClojureScript and ClojureScript as yet another step towards the dream of Clojure and Clojure. Because even more of the compiler has actually been implemented in Clojure, well, really ClojureScript in this case. All right, so it's a little bit hard to keep all this in your head because there's a lot of different environments that are involved. And so I thought some graphs might be a little helpful to understand what's going on here. So in a normal ClojureScript program, we have the ClojureScript, which is a Clojure program running on the JVM. And we give it a ClojureScript source file. And what it does is it generates JavaScript. And that JavaScript runs either in Node.js or in the browser, or in Rhino, or a bunch of different other JavaScript targets. ClojureScript and ClojureScript starts with the same thing, the ClojureScript compiler running on the JVM, implemented in Clojure. But instead of feeding it one of our end programs, we feed it the ClojureScript source, which has been ported, the ClojureScript.clj ported to ClojureScript.cljs. These are just tags that sort of indicate the whole full thing that's being built. But that outputs JavaScript, and that runs on the browser. And then we give a ClojureScript program to that. And this is now running in JavaScript, compiling a ClojureScript program also to JavaScript to run in the browser or Node. All right. Now, the real goal of this project is self-hosting, which the first few steps are similar. And one time, you do the compilation from the Clojure version of ClojureScript, or the ClojureScript compiler running on the Clojure version. Sorry if I'm a little, this is a lot of repeating of Clojure and ClojureScript. But okay, so we're outputting, just like above, we're doing the same thing. But once we have this built, then we can feed back in the same sources and hopefully get basically the same result and do that as many times as we want. And this would allow us to basically, we've bootstrapped away from the JVM and from original Clojure. And so this in a sense is really the ClojureScript and ClojureScript, the end goal. It's not quite there yet, but I think there's not that much that needs to be done. There's just some macro var and namespace issues in core that need to be addressed. And then once you have that, you can compile itself a bunch of times if you want to, make tweaks. And eventually, you're obviously going to take a program and compile it for actually using as an end user. All right, so that's what ClojureScript and ClojureScript is. So now I'm going to talk, that really covered, I think, probably the most interesting part of the talk, especially the examples. Hopefully that inspired you to understand what this, in small part, what this is about. But now I'm going to go through some of the steps. And this is going to be more of a chronological overview, more than a functional overview of the process that I use to basically implement this. But first, just do a really quick review of the ClojureScript compilation process, which is very similar to the Clojure process. We have the reader that does basically a pass through a string or file, returning tokens, and there are some magic things that happen to transform that. And then we have the analysis phase, and in particular, that does macro expansion of forms. And then we compile and emit. The compiler calls the analyzer to do the analysis, to build up the AST, and then the compiler goes through the AST generating JavaScript code. And finally, sort of have a line here. This is normal ClojureScript. A break here where we go to a different environment and we load the JavaScript code and run it. So that's just a quick review of that. So the beginning of this whole thing was several months ago at ClojureConf in November. Chowser and I got together and should have been listening to sessions and did some hacking, and we actually got a real minimal ClojureScript REPL working that was written in ClojureScript, or basically, the first stage of the port. And what that involved is we took the compiler and analyzer.clj files from the ClojureScript compiler, copied them to the ClojureScript directory, and then we had to do, which was the thing that allowed this whole process to really be possible, and it wasn't obvious at first what we needed to do here. But basically, the way we bootstrap this is the ClojureScript compiler has this one atom, global atom called namespaces. And what that basically is it's a large hierarchical map that contains all your namespaces data, and in those namespaces, the var data, in quotes, because they're not really vars in the Clojure sense, but they're basically equivalent, functionally equivalent to vars. Okay, so one of the other things is some of those files have some macros in them, not many, but just a few, and because of the way the normal ClojureScript compiler works, you have to move those out of there if you want to be able to use them in the code itself. And so move those out, use the use macro mechanism to pull them in. There's a bunch of stuff that needs to be stubbed out, like file IO and stuff, because that doesn't work yet. And we also rewrote the emit constant multi-methods as a protocol, because the multi-methods use class typing of the data, and so that doesn't really work well on the JavaScript side, and so we rewrote those as protocols. Then we added a little bootstrap magic, and voila, we had a very simple REPL that could load to the browser, and we could compile forms, and but it was very, very limited. I mean, it would do specials and normal forms, but it didn't have macros, so you didn't have things like defun or even fun, because both of those are macros. So you have to use fun star, which is the special underneath that all. But that gave us hope that this is possible. And so after ClojureConj, in my free time, I've been hacking on this, and I took basically that same code, made a node REPL version of it. Again, no macro support and all that. But it ran in Node, and like I mentioned before, I had to create this Goo.js to basically allow the Google Clojure library to work in the Node environment. And then the namespaces thing was really a hack. It was a necessary hack, but it basically, after the whole compilation process, all the files are processed, you have this big namespaces variable for all the namespaces you've processed. And so one of the things I did early on is switch that so that it's dynamically generated per file, and that data is added to the end of the each compiled file. And when those files are loaded, that's swapped in and built up dynamically. So that gets rid of that manual post-processing step. Let's see. All right, so that didn't have that much impact on the final result. One of the next steps is porting the reader. So the ClojureScript has some reader code, but it's fairly limited because it really was just designed to handle data, not code. And so one of the things I did is port a bunch of the Java version of the Lisp reader over to ClojureScript, and then a couple months later discovered that, of course, I should have realized a lot of people had implementations, more full implementations of readers out there. But anyway, so got that done, like syntax quote and unquote, which is really important for the next step, which we'll get to. Anonymous functions and the function argument reader. The comment reader was there but disabled because by the time you got there, Clojure had already removed comments, because in normal ClojureScript, the Clojure reader is used to parse the sources, not the ClojureScript reader that's included in ClojureScript code. All right. So basically, macros are defined almost always using the syntax quote and unquote, which is why I needed to get that working first. So def macro. It is itself a macro, which is a bit challenging. And in ClojureScript, talking normal ClojureScript, what's in ClojureScript right now, macros are defined not on the ClojureScript side, i.e. the runtime of the JavaScript, but on the Clojure JVM side. And so those are expanded before the JavaScript is emitted, and only the emitted result, right, only the JavaScript is emitted. So I poured a def macro from I don't remember, yeah, so from Clojure to core in ClojureScript. And now what that allowed was that I'd start up the REPL and I could define new macros. So that's very cool, but you still didn't have defun and things like that unless you cut and pasted them into the file, because it only works runtime due to the split between the Clojure compiler's runtime environment and the emitted output environment. So this is still a bit of a hack, and this is in the code still. There's better solutions that we could come up with this, but this is it's gotten it going. So I added a new CLJS def macro, and this is defined on the Clojure side in a macro file. And so I pull it in using use macros, and this allows me to define predefined macros when I actually compile the ClojureScript and ClojureScript compiler. So, anybody confused yet? But the result of this is that now you have the ability to use all the nice things that you expect and maybe don't even realize are macros, like defun and loop and let and all those good stuff. And in addition, I ported the destructure function, so now you can actually do destructuring in those macros. So that's good. So that was basically step 6. And I didn't have these numbers on it. Those are part of the presentation. But so one of the next steps was types and protocols. And one of the challenges here is that the implementation of types and protocols in Clojure and ClojureScript is that one of the ways they work is they put metadata on symbols. And then these symbols that are passed around between the different functions, that metadata is part of what controls what happens. But here's a problem. In JavaScript, in ClojureScript, symbols are just specially prefixed strings. And like in JavaScript, you can't add new attributes to a string. Actually, technically you can. Of course, there's always a but with JavaScript. You can add new properties to a string, and JavaScript will automatically coerce your literal string to a string object, add that attribute, and then promptly converse back to a normal string and drop those attributes. So you can never actually get at them. You can't actually get at them. And you really wouldn't want it to be that way anyway. So one of the things that I had to do in order to get types and protocols working is convert from using prefixed strings for keywords into real objects for symbols. And that was referenced actually in a previous talk. And there's some edge cases where this could probably have some performance impact, but really the main place that I could see is that if you had maps or objects that were indexed by symbols, which I don't think is all that common of a use case, then you could hit some performance issues, or it may not perform quite as well.
Was that just for symbols or for keywords also?
Just symbols. I didn't. You can't have metadata on keywords, so I didn't need to do that. So keywords are still, keywords you really want to be fast because those are used for lookup all the time. And so now I was able to port all the type and record and protocol functions to ClojureScript. So now the result is you can define all those at runtime or at compile time. Now, star NS star is a little bit weird because namespaces are weird. They are a Java object, but they are magic, global, mutable objects. And so one of the problems with the star NS star, actually I call it a symbol there, but it's actually an object, is that it refers to the live namespace that you're currently in. And so if you do a def in the namespace you're in, it automatically appears in star NS star inside that, which is a bit of a problem on the ClojureScript side because the namespace's atom just contains normal Clojure data. It's a hierarchical map. And so if we take a copy of the namespace we're in from that thing and we do another def, then in the def special, we would have to do something, some magic and update, something over here with the current state. Or another option, which I went with, is I just dropped star and a star completely from ClojureScript and ClojureScript, and went with replaced it with a symbol, star nsym star, which just contains the symbol of the current namespace you're in. And then when you need that data, you actually look it up. And so I changed the places where that's used. All right, and that allows some more namespace stuff to work a little more logically. On the Node.js side, for the Node.js REPL and the Node version of the compiler, I implemented file I/O support, and that's what allowed that final example I showed to work, which is doing statting and dir, listing files in the file system in order to find dependencies and all that goodness. One of the outcomes of this step is that I was able to port load file, and so load file works. And load file is a pretty critical function for a lot of things, like require and use. But anyways, yeah, that's the result of this. And one of the big outcomes for me for this project is that now instead of copying and pasting for doing testing, I can actually load file up a test file and run tests from that. And so this was actually, for development, this is a big step because now I can, load core test.cljs and run it and verify that a lot of things are working or discover which things aren't working, like Unicode stuff. That was fun to discover. All right. And there's a bunch of miscellaneous stuff that I've done. One thing to note here, architectural difference, and I don't know if this is good or, so the output streams I've actually converted to be output functions, not streams. And because in like a browser environment, you probably, if you're going to want to display any of this to the user, you probably actually want to be doing DOM manipulation. And so these make really more sense in that environment to be functions that are invoked by the print function rather than some stream, which there really isn't a concept of anyways in ClojureScript. So is there a question? No? Okay. Porting the Clojure file is one of the, that also allowed as part of the actual, the full compiler port. Line numbering pushback reader, that's really nice to have when you're, most of what you deal with is when it breaks. All right, so like I mentioned earlier, self-hosting is still ongoing. It can't compile itself over and over again because of some issues in core that relate to the macros, namespaces, vars interaction. One of the things that I'm probably going to do pretty soon is convert vars from just being another map inside the namespaces structure to actually being real var objects. Because right now you only have quote vars in ClojureScript and ClojureScript, not an actual var concept. And that's why I had to do the nil at the end of that function that I showed you, because when you do defs in ClojureScript and ClojureScript, you get back the value that you def, not the var of what you defed, because there really is no var. Is that dimming out when I do that? Or is it just on my screen? Anyways, never mind. All right. Yeah, so the hack I showed for quote self-hosting is you copy the precompiled core.js, and it's a big hack because that's where most of things live. But the full self-hosting, I think it'll get there if I can find some free time to work on it, or other people want to pull it down and poke around. There's some very weird things where like in the core macros file, if you define a function with multiple arities, then something basically it breaks dependency handling in the compiler much later. And I have no idea why that happens, and just haven't had time to track that down. But anyways. All right, so finishing up, hopefully a few minutes for questions here. All right, so the future. There's still quite a bit of work to do around require, use, and class path issues, because once you're in Node or in the browser, what does class path mean? If you're in Node, you could have some sort of equivalent to a class path where you look in a bunch of places to try and find new requires that haven't been precompiled. But in the browser, you don't really want to be doing a whole bunch of 30 AJAX request to try and find, your dependency on your class path. So I'm not sure exactly what the resolution is there. And the problem here is if you do a require in an NS or an explicit require using the require macro or function, actually I don't know which it is, then what it's going to emit is a Goog require, and the Clojure library is going to say, well, I don't know what this is, because you haven't done an add dependency thing yet. And so that's still some work to do. If you do a require of something that somewhere else in what you've built, that require has already been compiled during the initial compile phase, the require will work, but only if you've pre-compiled it. So doing dynamic loading of new dependencies when you create a new namespace doesn't work yet. The debug REPL I showed you, it's very basic, and there's a lot of weird sharp edges. And my vision for it is sort of like Firebug, but for ClojureScript. And I think that would be really cool. And there is a version called Firebug Lite, which doesn't require a Firefox extension and has most of the functionality. And I think that would be a great thing to look at to see, what of that functionality can we port over to. Okay. All right. Self-hosting, obviously mentioned. I'd like to get some of this or all of it merged upstream into ClojureScript. And also, I haven't merged since the branch back in November, so there's a lot of ClojureScript functionality that I need to merge forward to. I think more use of Node in this field would be interesting. Just as a note, the NPM, the Node Package Manager repository, is probably the fastest growing module repository out there. And so in case you thought Node was a passing fad, I'll just let you know that in the next year, the number of packages in the Node package repository is going to surpass the Maven repository. There's about 25,000 now, and within a year it'll be 50,000, and it's exponential growth curve at the moment. So whether you like that or not, Node is growing in popularity very rapidly. So there's a bunch of performance work that could be done. I haven't even pulled up the V8 profiler to look at where the hotspots are. There's also an interesting project called asm.js out of Mozilla related to ScriptAnnie, and this is a strict subset of JavaScript that allows you to, it allows the JavaScript JIT to generate highly optimized. It's basically typed JavaScript code, and they use some tricks to communicate that typing. And the benchmarks show that it gets within about 50% of native C code. And that's pretty cool, which is basically Java range. And so there might be some interesting places. This isn't ClojureScript specific, but there might be some interesting areas to explore there with ClojureScript. And then there's all kinds of cool new applications that I haven't thought of, but all you might have in your mind already that could be done with this. Some more links. And a bunch of people to thank for this. And I think I've got 2 minutes for questions. So